What's going on, everybody? Welcome to UW Marathon CS540 Week 5 Probabilities Part 2. If you're new here, welcome. Be sure to check nearlyblog.com and click this image and you are able to view this page. So in Part 1, we mainly talk about some axioms and also joint marginal conditional probabilities and also Bayes rule. And in this tutorial, I would like to introduce some other useful equations which might not be in the lecture notes but appears in our tutorials and also in our exams. So let's jump into the tutorial. So last lecture we actually introduced a really important concept that is independent. So in exam, if we want to express independence, then we just use this symbol. So this symbol here means x and y are independent. So if x and y are independent with each other, so what are the probabilities they have? Or you could say what equations we can derive from this. So first of all is by given condition y and calculate the probability of x. Since x and y are just independent to each other, so there is there's no relationship to y, and it just equals to probability of x. And the same thing here for y. By given the condition of x, it is just the probability of y. And next is another equation, that is the probability by giving both x and y. Calculate the probability of both x and y, then it will just equals to x times y. And the reason here is very simple, since they were just independent, so we just times them. Next, I would like to introduce something else, which is the condition independence. Since we know the condition sign here has a lower precedence, so actually it will first see like this. So you can just imagine here is a bracket. So x and y are independent by given the condition of z. So what are the equations that we can derive from this? So first of all is x, y by given that it is actually equals to p x z times p y z. And the reason here is by given the condition of z here, actually x and y are independent. So you can actually see some similarity from these two equations. Since here x and y are independent in all circumstances, so actually when given the condition z, then it's just a similar equations. And another few equations that we can derive is x, y, z. So by given the condition of x and y and z, what's the probability of x here, which is actually equals to this one. The reason is when given the condition of z, x, y are actually independent to each other, so there is y here is not necessary, since it doesn't affect the probability of x under the condition of z. And similarly, we have y, x, z, that is equals to y over z. So please pay attention. Here is x and y are independent to each other under whatever circumstances. But here, x and y are only independent when by given the condition z. So let's take a look to another really important idea here. So as we know, actually we appear some sign here. So for example, I have that equal probably here first come to a simpler example. So first of all, I have a small y equals to larger y and p x y. And I give a very simple example here. So there are a capital X and capital Y, and they have four circumstances: 0, 0, 0, 1, 1, 0, and 1, 1. So there are four circumstances. And X and Y, both X and Y here can be either 0 or 1. So what does this here mean is the small y belongs to the capital Y, and actually capital Y here is can be either 0 or 1 here. So it will just add them together. I will like represent here as y1 and here is y2. So let's derive this function. So it will equals to p x y1 plus p x y2. It's just because of this sum sign here. So let's take a look for this. When y equals to 1, that is 0 here. Probably we can add another condition here. So for example, x equals to 0. So when x equals to 0, y1 equals to 0. So there are actually four cases here. Sorry, one case is here, that is 0, 0, and here is just 0, 1. So actually it's 1/4 plus 1/4 equals to 1/2. And what we can derive from this equation is actually it just equals to p of x equals to 0. So here is a derivation that is for whatever. What color should I choose? Okay. So for whatever, for example, here is small w equals to capital W here, and we can have x, y, z, blah blah blah, and until small w here. So here it will just equals to x, y, z. Probably dot 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 like this. Probably I should change to someone else like x1 or x2, x3 until this one, so it's less confusing. And actually the reason why we can just cancel the w here is just like from this derivation, since the w here when added all small w, or you could say all the options of w here, it will just equals to 1. So the same case here. However, there is another trap somehow. So just now we talked about, probably I just use x, y, and z here. Oops. Capital W, it equals to x, y, and z. However, there is always a trap here that is like this. For example, x, I just select it, and here is small omega. So here is the question, whether this term will equals to this term or not. And here is a question mark. And the answer is no. We can actually derive from this equation. So this term is actually, you can put something like this. And we just have the big omega here. And we divide by y and omega. So what does this mean? It's actually, you can put many terms together. So for example, xy omega 1 and p y omega 1 plus blah blah blah. So change the 1 to other numbers. So the small w here is all the possible options for the omega, sorry, the capital W. And actually, here is the thing, that since the denominator is actually different, we so for example, these two terms, the capital Y and also W1 and W2, their probability actually different. So we are unable to add denominator together in order to achieve X and Y. So this is why if we have this term small on W in the condition term, instead of just the previous term, which is here, or you could say here, so if W is in the condition term, we are unable to perform this kind of calculation. So just please pay attention to this point. I think this is the end. So I included some really important formulas. I hope this is helpful. If you have any questions or concerns, please feel free to leave comments below. Otherwise, I will see you in the next tutorial.